Hello all. I am Professor MB Nigade from AISSMS IoT, Pune, working in Department of Engineering Science. The today's topic of fundamental of engineering course. In engineering course, the part one is conic section, and conic section is classified into the ellipse and concentric circle method, then rectangle method, oblong method, arc of circle method, rhombus method, and basic locus method like a directrix focus. Next is now the parabola, that is a rectangle method, method of tangent, and basic locus method. Then hyperbola, that is rectangle method, then rectangular hyperbola, and basic locus method like a directrix and focus. In conic section, the ellipse, parabola, and hyperbola are called as a conic section because these curves appears on the surface of cone. When it is cut by some typical cutting plane, then it may generate a different type of curve like ellipse. When it is cut the section plane through the generator, then we get the ellipse. Then same cone is now the cutting exactly as the section plane is now the parallel, then we get the parabola. Then the section plane cut parallel to the axis, then we get the hyperbola. Means the cone is now the cut at different position, then we get the different type of shapes or different type of curve like ellipse, hyperbola, and parabola. A common definition of ellipse, hyperbola, and parabola: there are locus of points moving in the plane such that ratio of its distance from fixed point and fixed line, the remaining be constant, then it is called as eccentricity. And for eccentricity is nothing but the ratio of the fixed point to the fixed line. And whenever it is less than that of 1, it is called as the ellipse. When it is equal to 1, it is called as a parabola. When it is greater than that of 1, it is called as a hyperbola. Okay, and second definition of ellipse is nothing but is locus of a point moving in the plane such that sum of its distance from two fixed point always remaining be constant, means sum of its length of major axis like a plus a is equal to 2a. Okay, and in ellipse there is a two focus, one is focus 1 and focus 2. Okay, first we can see the rectangle method, and this is step we are taken. In the rectangle method we have taken the major axis is 100 centimeter, another minor axis is now the 70 millimeter long. First draw the rectangle. This is 100 millimeter we are taken as a major axis. Then in noted notation we are given a and b. Then take the exactly midpoint of that 100 mm and draw the minor axis 70 mm, like 35 mm above the AB and 35 mm below the AB. Then the name, the notation is also important, name as a CD and to complete the rectangle first. Then divide this line into the 5 equal parts. Four equal parts. Then divide this line is also is in 4 equal parts. Then join 1 to D. Then join C through the 1 to 1. Then next we getting the intersection point. Second join to 2 to D. Okay, and join C through the 2 to the 2 points. Inclined line. Then we get the second intersection point similar to the 3 to D. Then C through the 3 and intersection at the point of 3. Then we get the third point. Okay, then complete curve we are getting here. Similar construction from right hand side also. Divide the line into the 4 parts and joining all the points, 4 points, 1 2 3 4, okay, to the D point. And then there is a, from the point of C there is a one line is now drawn and intersection at the point of 1. Then another point like a line like a C to 2 and intersection at the point of 2. Then another is now the 3 intersection at the point of 3. We get the 3 points here. And to complete another same structure from below also, and to complete the rectangular type of ellipse here. Next is oblong. Then there is some inclinations. Okay, only difference is the inclination is there. 75 inclination. Okay, draw the rectangle. Then parallelogram is called a parallelogram. Then similar major axis we can draw here 100 mm. Minor axis naming as AB. Minor axis is 70 mm. That is C and D is minor axis 35 mm above the AB and 35 mm below the AB. Then divide this line into the 4 equal parts. Then divide this horizontal line into the 4 equal parts. Then joining the 1 to D, 2 to D, 3 to D, and 4 to D, and joining the C to 1 to 1 intersection, C to 2 to 2 intersection, 3 to 3 intersection. Then we get the 3 points. And similar like a second in the right hand side, 1 2 3 4, divide the line into the 4 equal parts and join all these points. And similar structure from downward side also, we get the complex ellipse. Next method is the ellipse directrix focus method. In this directrix, first draw the directrix of suitable length and to find out the midpoint, and divide this how much distance. The point F is 50 mm from the line of AB, and the point P is moving in the plane such that ratio of the distance from the F and the line AB remaining be constant is equal to the 2 by 3. The eccentricity is what? 2 by 3. Therefore, draw the vertical line AB and the point F is of 50 mm from it. Okay, to find out the midpoint of AB and find the 50 mm. Okay, this is directrix. 50 mm we draw is a focus. Name the second part of the F, and it is a 20 mm and 30 mm. Okay, this is a 20 mm and 30 mm. Is divide this line into the 5 equal parts because it is 50 mm. Then this is vertex. V is the vertex. Then draw the this is a 45 and this is 30. Now 30, 40 and 50 distance were cut in compass. Then draw the curve, and this is the ellipse. Okay, thank you very much for listening my video.